I'm Gabriel Hernandez. I'm here for the HTML5 meetup group because I develop web applications. HTML5 is hopefully going to set us free in a lot of ways. Tonight's whole big thing is about the app cache. I'm hoping to get some good, solid, usable understanding of the API and code, actually see how some of that works. Short of that, maybe there's coffee here.
Hi, my name is Marian Panic. I've been working as a web developer for the last 5-6 years. Tonight I'm especially excited about hearing how caching can help us speed up our web applications, because I believe that the speed is the next big thing with our web apps.
Hey, I'm Omar. I'm a web developer for OneRoof. I'm not sure what to expect at this event, but HTML5 excites me because I've seen some pretty incredible things done with it. I'm not a big fan of Flash, so I'm glad to work towards the entire internet converting to HTML5.
So, some of you already know me. My name is Peter Lubbers. I'm the Director of Training and Documentation at Kaazing Corporation. Kaazing specializes in HTML5 WebSocket Gateway. And I actually also co-founded the San Francisco HTML5 user group. It was only in April that we started it, and we already almost 900 members right now, so it's been just great. So hopefully we'll reach 1,000 before the end of the year. So I want to tell you a little bit about HTML5 offline web applications. Pretty exciting new feature, and I've been working with it a lot lately, and just really excited about what you can do with it. But there's also quite a few little gotchas, little things and tips and tricks, if you will, for working with them, how you can develop these, how you can debug them. And so we'll look at how you create it. So I have an actual running example here. And then there's some server configuration I'll step you through, and I'll also make these slides available. So HTML5 offline web applications is a new specification. It's also known as app cache. And the HTML5 specification in general is located in these different URLs, both from the working group as well as the W3C. But the specification for HTML5 is about 900 pages long, and about 600 of those pages are really, shall we say, of interest only for browser developers, right? It is the kind of language that you see here, which details everything you need to do to create an interoperable spec. Now, one of the aims for HTML5, and this is that famous 2022 date, is to have interoperable implementations in multiple browsers. Now, what does that mean, right? So that means that every browser would work the exact same way, and to get there, it needs to be an incredibly precise specification. So you get into this kind of language where, for character as it's being read, what to do for the browser. Well, we're not going to go there. So in the next hour, I'll talk to you more about sort of the human readable version and what it really means for you as a developer or front-end designer or anyone that has an interest in this. So the most common use case, and I think of almost every feature in HTML5 has sort of a demo that is done over and over again. If you have web workers, it's the prime number calculator. And of course, for offline web applications is the airplane use case. You go on a trip, you're not connected, but you still want to use your web applications. You still want to use your websites. And really here we're not talking about just applications only, or also about websites. In fact, it can be very useful for websites. Now, you can use regular browser caching, right? So you can have, if you access a page, most likely some parts of that page, the assets that are part of it, maybe the images, the CSS and so on, all of them will be cached in your browser. And the traditional caching is not something you can really rely on for offline use. Take, for example, I had in preparation for this talk, I was coming back from Stockholm, and I opened the page, the actual specification, in my browser at the airport. Then hibernated the computer, went in the airplane, 10 minutes later, opened the computer again. There was my page, all perfectly there. Now, accidentally hit a link that went to one other specification. File was not available. Well, no problem, right? Unable to connect. This is the sort of use case. Well, I just quickly went back. Oh, the other page was also gone. So now I was locked out of everything. So it goes to show that even though as a developer you can access or you can specify caching settings for your pages and for the CSS and for the HTML and the images and so on, there's also browser settings at work, and a combination of that just makes for a fairly unreliable set of parameters for being able to go completely offline and being able to use a complete application. So if you want to set regular caching, if you want to affect regular caching behavior, you can do that, for example, in Apache. There's a .ht access file, and you can set caching for, let's say, JPEGs and PNGs, and you can set these to have the right values. Right? This is actually coming from a great resource for all of you really to look at. It's called Html5 Boilerplate.com. Html5 Boilerplate is a new resource. It's a pretty recent something that Paul Irish and Divya Menon came up with and have shared that it's available for free. One of the things is to optimize your web apps, you need to specify caching, right? But that's sort of the browser caching, and it's not something, like I said, even if you use the best settings, your apps will be fine and fast, but they'll still be expecting to always be online. And HTML5 web apps, offline web apps, sort of change that, make it easy to do that. The other thing with caching, there are ways to do prefetching of content, prefetching of images and other things in regular HTML, even in HTML4, if you will. But typically caching works based on whether you've visited that page. So you visit the page, and now it's in your cache. It may be there for a little while, it may be there for a long time, it may never expire from the cache. In fact, some of the newer browsers, it's extremely hard to get things out of the cache. Even if you just clear your cache, I found that some browsers will hang on to images for a long time. So HTML5 offline web application is a new feature that allows you to cache pages in a new cache, a new compartment, the application cache, even without visiting those pages. So I can basically access a page, and that page might have a list of files that are part of the application and say, look, cache me all of these files, put them all in the application cache, and that sort of allows you a very quick and easy way to prefetch content. Now, prefetching content, you may or may not like that, but it's available, right? It's taking bandwidth. You don't want to unnecessarily do that, but it is an option. And with this application cache, with the offline manifest, it makes it very, very easy to do. HTML5 also gives you an offline detection mechanism. There's events that fire that you can listen to and take advantage of, right? And maybe create applications that are available online, detect when they go offline, and have either temporary pages that show up, but you can even do other things like maybe temporarily store things in things like local storage, session storage, local storage, or other APIs that HTML5 provides that are very powerful. You can even store SSL pages, so pages that are served over HTTPS. It doesn't matter; you can still cache them in the application cache. Okay, so which browsers really support that? The source that I use for this information is a website, a great resource also for all of you that are interested in HTML5. caniuse.com, really great resource because this browser support changes all the time, right? So it's always good to to go to a site that has the latest and greatest. Now, this is not guaranteed to be up to date, but it's getting a lot of traction. A lot of people go here to check it. So you'll see that it's in all the modern browsers, not in IE. So for something like that, you might use an offline emulation feature that is part of it's part of Gears. And there's also a new HTML5 Gears project by Brad Newberg from Google. The link is there, and I looked at it only briefly, so I haven't really fully tested this out myself, but it's pretty promising that you could then, typically the way emulation works is you include some sort of library in your application, and then if that feature is detected, if it's not there, you can, it's made available in some other way. Now, exactly how they do it, I don't know, but it's there. Okay, and let's take a look at how do you actually create these applications. All right, so the first part of a offline web application is what's called an offline manifest file. It doesn't have to be called offline manifest, but it has to end with the extension .manifest. This manifest file, the most simple way to think about this would be a file that has a list of files you want to cache. And at its most basic form, it just needs to have the words cache manifest at the top and a bunch of files that you list that you want to have cached. So in this case, I have an index file, a cache file, a CSS file. I could add some JavaScript files, a couple of images, and you can even have references here. You notice that most of these are just files that look like they're at the root of the site, but you can also have paths in there. In fact, you can even have complete URLs in there as well. Now, if you took a look at the top of this file, so you can have, cache manifest has to be the first line of this file. And comments can be prefixed with a £. After that, a list of files will be cached, right? That's the default behavior. If you list a file in that cache manifest file, they will be cached. But there are actually three, let's say, groupings that you can apply. So there's also a network section, and then there's a fallback section. I'll get into some more of the details later. To use this manifest file, all you need to do is add an attribute to the HTML element. Now, in HTML5, there's a much more relaxed syntax for expressing, like writing your HTML pages. Typically, all you really need is the new doc type, and then the title of your page and the char set. But you don't even really need the HTML element in it to be valid HTML5. But to add this manifest, you do need it. So in this case, I've added the manifest attribute and added that reference to the offline.manifest file. And then you use your page, you access your page. The first thing that will happen, but it depends a little bit on which browser you're using, is typically that your browser will prompt you whether you want to store files on your machine locally, right? If you are allowing the browser to store files on that application's behalf. For example, this is the UI that comes up in Firefox. I noticed that some browsers don't prompt you at all. So this is something that browsers may opt to do or may just simply not do. But it would be nice that all of them would at least ask you, because you could imagine, since you could put a ton of files in the manifest, you could theoretically just get some kind of attack with just loading your cache full of files. And for that reason, there are some default settings, default number of megabytes, like in Firefox is like 50 megabytes for offline usage, right? So you can't just simply put gigabytes of stuff into someone's cache. Okay, so back a moment, and I'll show you how it works in action in a little bit. But the three sections. So I mentioned there's the cache manifest at the very top of the file, and that has to be there And if you put files underneath that, they will be automatically cached. But if you want to specifically write a cache section, then you need to add cache colon, uppercase cache colon. This file is extremely unforgiving, or I should rather say, the rules set in the spec are very unforgiving. The slightest mistake and the whole thing will just bomb, and then nothing will work. In fact, you'll get some really curious results. So if you have a cache section, it has to be cache and then colon. Don't forget that colon at the end. I've added it there everywhere just so you would see, because if you don't do that, then the next line will be misinterpreted as, or it will be interpreted as a file, and then there's not a cache file, and then the whole thing will blow up again. So it's very finicky. Comments, they start with a pound sign, and you can actually have multiple manifest files per website. Like you could actually, let's say, break up your website, think of like a tree structure, have an offline manifest at the top, and then somewhere lower down you have a completely different manifest, because you're getting a sort of cache area which is based on the URL of that manifest file, right? So it's not even just a single origin, it's actually a complete key, a bucket for that manifest file and everything that comes in it. If you access a site, let's say in Firefox, and that's the same for caching, right? If you access a site in Firefox, you create this application cache, then it's only for Firefox, right? So if you access the same site then in Chrome or Opera or Safari, they cannot access, the files in the Firefox cache. So they create their own cache. So you maybe, if you access it in 5 different browsers or 4 different browsers, you can get 4 different caches. All right, so the cache section. This is either you can leave the cache colon part out if you list files right there at the top, because that's sort of the default behavior that they will be cached. You can put 1 file per line. You can't put wildcards in there. You can't put star.html or something like that. It has to be specific file names. You cannot put, for example, the bookmark with a pound and then a section of the page. That's also not allowed. It's case sensitive. Be very careful if you type in .jpg and it's in uppercase, whereas the file is really in lowercase. Even if you're on a Windows machine, most likely this will be served by a case-sensitive server. Either way, you'll get into all kinds of trouble if you don't put the right case in it. Now, the other thing is, if you access a file and it has this manifest reference, this attribute, then that file doesn't need to be in the manifest to be cached. So you'll be sort of lazily added to the application cache if you just have the reference to that offline manifest file. And I'll show you that in practice in a little bit. But keep that in mind. For example, if I have a file, an index.html file, and I expect all my users to access the site through that file, then I don't actually need to add index.html to my manifest file. However, it's a good practice to do it anyway, to explicitly list it, because the problem you'll run into is somebody will access it, let's say, from a sub-page of that, and then they'll go back, and sure enough, you hadn't listed it, and the file ends up in the wrong place. The next section is the network section. Network section, as it sort of the name implies, is a list. It's also known as the online whitelist. This is a section in which you list files that the browser should get from the network, bypassing the caching. So these files will not be cached, and they will be pulled from the network if, of course, you're online. Right? So since it's offline web application, that's not a given. And there's another option for that as well. So you can also specify, in this case, star. That means that basically everything you're getting is from the network. And there's a sort of a clever way to do something with this later that I'll explain. Then there is a fallback section. And the fallback section contains sort of let's say a pattern, like a namespace with a fallback page that is served in case files are not available. Again, this is a very common thing because it's offline web applications, right? So you may not be online. If you can't access one of the resources that you're trying to go to, then the fallback content will be served. So the question was if that was a typo / space fallback, and the answer was no, but each section has a different semantics. Right? Okay, so let's take a look at this in action. I'll try to keep the mic in hand as I do this. So one-hand demo. Okay, first thing I need to do is I need to actually, so I have an offline folder with some demo files. It's a very simple little website with a couple of pages on it. An index page, a cache page, a network page, a fallback page, one of each, just to kind of demo the functionality. It's not an actual website as such. One of the things about this is, right away, I can't just open these files from the file system. I need to actually serve these up from a web server. And to do that, I'm just going to do it very simple. I will put the mic down. Okay, so what I've done is I've taken the files that I had in that folder, and I've actually navigated to that in a terminal, in a command prompt, and started Python with the simple HTTP server that's part of Python. Very handy for quickly hosting some files on your local machine. I've done that, and I've hosted this, and I've hacked my host file to have a domain called offline.example.com. So I've hosted this at offline.example.com, but it's really my own machine. I'm hosted that on the simple HTTP server from Python, and now it's up and running. This Python server is serving files. And this is a simple index page. And you notice that right away, as I access it, it prompts me, do you want to store it? This site is asking to store data on your computer for offline use. Okay, allow. Some browsers don't prompt you for it, but it's just like geolocation and other features. This is something that the browser is trapping, and there's no way you can bypass that for good reason, right? But the weird thing is that geolocation is implemented the right way in all the browsers, at least somewhat similar, whereas this, in Chrome, it doesn't ask me anything. So it's just, I guess it's okay. And also there's no UI for upping the limits and so on, but that may be coming, right? Okay, so I've started out this page and notice that the first thing that it says it's initial status online and then uncached, and then so I'm actually trapping all of the events that are fired on the application cache. And I'll come back to that in a little bit. But I'm also listening to see whether I'm online or offline, and I've set an event handler for the online and offline events. So now what I'll do, since Firefox is a really handy work offline feature, notice that right away the event fires, the offline event that I was listening for, and I've updated the page. So now I'm offline. Okay, so notice that I have a few pages here, right? And here's the index page, that's this page. And then there's a cache page and a network page. Now, in the offline manifest for this page, let's take a look at these pages in the text editor. So this page simple HTML5 page with a manifest reference. That's the index page. And it references this file. Now this is the file. Notice it's pretty similar to what I showed you before. Notice that I've got the cache HTML file in the cache section. And I've got the network section. I have network.html. And I have fallback.html in the fallback section as a sort of a general fallback page. Okay, so based on this setting, I can now do something. I can go to the cache page. Now I'm offline, and now I go to the cache page. And even though I've never accessed the cache page, because I just cleared the whole cache, I can see the page. There it is. And I can also see the image that's on it, right? So that's because when I accessed the index page, it loaded everything that was in the cache section. And now, without going on the network, while I'm offline, it's actually reading in all of the files and directly from cache, so also extremely fast. Now, clearly you could do similar kind of things in regular HTML4. You can do prefetching of resources, and you can rely on caching behavior, but it's a little different from just listing them in a file and having them there guaranteed. Question was, can you cache FLVs, large video files? Yes. In fact, the little example I have here, I have two commented out pretty large movie files to an MP4 and a OGG file. You can cache any resource you want, right? Yeah, no problem. In fact, that's when you'll see you need these caching events. You need to be able to listen for these events and do things around it. Like if you have just a few files to load, the caching of the prefetching of those will be very fast and almost negligible, right? So you access the page, files are loaded. Not a big deal. But if you start loading serious amount of files or very large files, then you want to have some sort of progress indicator, some event that fires like, okay, wait till it's all done and then maybe tell the user it's now safe to go offline. And that you can do with these caching events. Going back a moment to this page, I'm offline and I have another page that's called the network page. And based on this configuration, what do you think will happen if I access this page? Yeah, so the idea is, yes, it would in fact load the fallback content based on this setting, right? Network HTML is not available, but then it should swap in your fallback page. So we just found a bug in Opera. One of the problems is, while you're using the offline cache, the application cache, there's also yet the old cache, the regular browser cache, also at work. So this is where I was going to say in one of the best practices, but I'll say it now, one of the tips and tricks and best practices, watch out for these false positives, right? Looking at this page, even if you're offline, doesn't necessarily mean it's the page you got served from the application cache. It could even be the browser cache. So you'd have to clear your cache and try it again. So there is a sort of a sequence of events that is very important and not very intuitive when you first look at this. You access a page, and that page has a manifest file. So the page is loaded, and all of the resources that are on that page are loaded. So you get images, CSS, JavaScript, all of the stuff that's on the actual page is loaded, and that's going directly into your regular cache as well, right? Depending on caching settings. The next thing that happens is the page is parsed, and oh, guess what? There's a manifest file. All right. With the manifest file, the browser knows, okay, this is stuff that has to go in the application cache, a completely different cache. So it can't, and to answer your question, like, isn't the browser smart enough to see the differences? Well, in reality, most of them are just going to download all of the resources again, even if that means duplicate from that one page. But most of these things are on different, they're caching different resources, right? So it's going to download all of the listed resources in the manifest file, and it puts this in the application cache. Then, if you go offline, you can access all of the cached resources. So if you then navigate to a file, it's available, right? If it's one of the cached resources. If you navigate to something that should be on the network, then you should, in theory, get the fallback content served. But now comes a very tricky thing. So let's say I update one of the pages. Now in this particular little website, I had the index page and the cache page. Those are pages that are that I might want to update. Let's say I make an update to the index page. The index page, and let's say I'm online. So I make an update and I refresh my browser. Now, what do you think will happen in that case if I refresh the browser and I've made a change on the server to that index page? The correct answer was nothing will happen. And the reason is, like, I'm online, and this is what I said, this is kind of confusing. You're online, resources change, you refresh the page. Why doesn't the browser just pull it from online when it can just grab that? No, the correct behavior, the spec behavior is that when you refresh a page, you always go to the cached version every single time. And the only way to, let's say, cache bust or application cache bust this is to update the manifest file, as he correctly pointed out. So you have there's only one way to get the browser to recognize that there are changes. So if I make an update to the index.html file, and then nothing will happen until I make a change to the offline manifest file. But since I don't have to make a change, I need to make some random change. And for that, it's a good best practice to create, and that's what you've maybe already seen here, see that version number, right? And every time I try to trigger that update, you could see I change the version number, make a change here, save it. But in general, if you're deploying real applications that use it, then you would actually version every time you make a change to your site. And this is where, in best practices, you would actually keep this version number in place. Also, you would use a script to generate this file from your latest resources, because it can get pretty hairy based on what I told you in terms of how strict all these things are. If you make a small mistake, they can cause errors. So I mentioned the versioning of manifest files, how you can create a comment and literally just use that as a handy way to also trigger these updates. You can check for browser support. You can do it in two ways. You can do window.application cache to detect whether that feature is available, the offline cache. You can also use Modernizer, great tool. If you haven't used Modernizer, that's a great way to check all kinds of HTML5 features. It's a very small JavaScript library you can add in your files and use. You can check for online and offline events. You can do that by listening for these specific events, online and offline. And based on that, you can perform certain actions, right? Maybe you write something to local storage if you're offline, and maybe you send something to the server when you're online. Now, to use the pages online, I've showed you already, some browsers support this, and then you have like a file work offline function. Other browsers don't support that, and some, it's not just a matter of time before they'll support it, some will just never do that. So for those, you need to sort of, pull the plug. And like I said, that doesn't work very well when you're serving files from localhost. There are all these application cache events. Now, like I said before, if you have a small site and there's a couple of files in your manifest, then it goes very quick, right? It's just loaded in the background and no big problem. But if you have a large number of files, and you want to do something or prompt the user that now it's okay to go offline. There was a question about this Flash video, so there could be a while before it's downloaded. You might want to listen for some of these events, and then maybe only when the complete site is cached, prompt the user, it's now safe to go offline. So for that, there's a whole bunch of these great these cache events. All of these are available, and they fire in at different times. And basically, it's checking, downloading, and then you get progress events for each file that downloads. And Chrome has done a fantastic job in creating this beautiful debugging console. Control-Shift-J. Okay, all kinds of error. So the Control-Shift-J brings up the Chrome developer tools. And in this case, you can see when this page loads in the Storage tab, you can actually look inside the application cache. Really, this is the only browser that has such a built-in feature. This is in the developer and beta channels of Chrome. It also shows all of the different events that fire as you're using the application cache. So if you're loading this page, if I refresh it, it'll say, there's another update just pulled in, and there's all the files that it downloaded. I can look at them, whether they're explicit or master. There's all the different settings on those. So a really good console to get a good view, because many times you can also listen for errors, and you'd be surprised, especially in the beginning when you're playing around with it, make one small mistake and you get an error, and then the whole thing is just sort of canceled. So, right. So here's a way from JavaScript you can easily check all these events and do something with it. Like I said, the thing that comes to mind would be waiting until it's ready to go offline. But there are many other use cases you can think of. A couple more. Error events, progress events, all of those you should be listening for. All right. Now I mentioned there's a little bit of server configuration that needs to happen to serve this manifest the right way. There's a couple of parts to that. The main thing is that the cache manifest has to be served in a specific way as a specific MIME type. And that is the text/cache manifest MIME type. Very, very important, because if you just, there's almost no browser or no server that will do this by default. So that's a problem, right? If you start serving it, it will either be served as text or as a binary file. Either way, the browsers won't understand it, and they can't parse it, and you get other kinds of errors. Now it's pretty easy to configure it. So in Apache, you can use the mime.types file for your complete server. You can also add something to the .htaccess file for a particular application. Here's some of the configuration. Another little gotcha. This is coming from my friends in the UK, Remy and Bruce, who wrote another HTML5 book. It wouldn't be very good if your browser was checking the manifest file and the manifest file was cached, right? Because then you get the latest version, but it's actually a cached version, so it's not changed. And this happens quite a bit. In fact, it's a good idea to add this sort of access plus 0 seconds to your expiry settings for the manifest file itself, so that the manifest file doesn't get accidentally cached and then you try to update. And because it's sort of your single point of failure, because you can change all the rest of your site, but it needs the manifest change to trigger everything, and then this would be your bottleneck. So a good little gotcha from them. Python. I will also make the files that I showed you here available online, maybe a small zip file. I'll point to it. I'll point it from the site. And in Python, you can open the mimetypes.py file and add this one-liner to your Python file. So for Mac, sometimes you don't have a py file. Sometimes there's a pyc file, and you can update that. I'll also drop a standard file in this zip file that I'll distribute later this week. Microsoft IIS if you're Microsoft shop, every single server, and this is just 3 that I just picked because they come across them a lot, but every single server has a way to set the MIME types. Every one you can use that. And then on to a couple of final tips and tricks. So we looked a little bit at the debugging part of it. So like I said, the Chrome developer tools, they have an option to go into the storage panel, look at exactly what's in your storage, and you can really dig into it. And somebody asked the question, like, where are these files located? I think you said, where's this offline manifest located? Well, offline manifest is really just a list of files that needs to be read by the server and doesn't need to be stored itself, right? You're not listing the offline manifest in the manifest. So the file is literally just a set of instructions to the browser. Here's all the stuff that's cached. If you want to know where the stuff is cached, it's actually on the disk. So if you go to in Firefox to the about:cache page, you'll get all your caches, including the offline cache device. Yeah, so your regular cache, look at it here. It's in Firefox, profiles, some cryptic name, and then cache, and the other one is in some cryptic name, offline cache. So it's right next to your regular cache. If you can actually access these files, and there's a really good add-on for Firefox. It's called the SQLite Manager, because Firefox is using SQLite internally to do a lot of the file caching and so on. So it's actually in a database on your file system. That's where all these files are referenced, and then they're actually on the file system. If you look at it here, this is just literally going on the file system, navigate to a folder. Now you see an index.sqlite. That's sort of an indication that things are in this SQLite database. And you can access, if you navigate down into this folder structure somewhere, you can actually get access to these files, the physical files that were in the cache. So we'll come to the security part in a second. So a couple of quick things. So the offline cache settings, you can change those. You can change your Firefox options, different. And the Firefox allows you to set specific sizes for how much can be stored. In opera:config in Opera, if you go to that page, you'll get a preference editor that allows you to go in detail and actually clear cache and so on. To clear the cache, that's very important when you try to actually debug this. Every time you would need to sort of clear the cache, because obviously you'll be looking at old files every time. So there are a couple of different ways to do it. Just put these in here for reference, but every browser has a way to clear the cache, and I've gathered all of that here in a little table for later. Now, one other thing you have to understand is the private browsing. So every browser has a private browsing mode or incognito mode and so on, which those modes don't allow you to store things on the file system. And so as a result, you may be, for example, if you do this in Firefox and it prompts you and it says, do you want to store files offline? And you say like yes or accept or allow, I think it is. You can click allow all day, but it will never allow you to, because you are in sort of a private browsing mode. Or like, for example, in Firefox, it's something like don't remember history, right? So these privacy settings, if you turn those up, then these things will not work. This is why it's a good idea to use something like a modernizer library to detect features, because they do advanced feature detection where they take those things into account as well. Not just is that window.application cache available, but is that available under these conditions, right? So good stuff there. Some security considerations. Since your application cache can be accessed from, basically it's stored on your system. So and it's stored under the URL of a complete manifest. So if this was a shared machine and someone else went on this machine and they went to the same site with the same things, the same manifest, then you get a problem, right? They might potentially access your data. So the key here is when you're developing these applications to not do things on a per user, like personal information shouldn't be just like local storage. You don't want to store sensitive data on a shared machine. So that's very important. I'll come to your question in a second. So to sort of recap some of the best practices, this manifest file is the browsers are very strict in parsing it, so be very careful and exactly follow the rules there. Use that versioning number as a way to sort of version the manifest if other files have changed. Use a pre-deployment script to collect maybe a Perl script before you go production. You know, add this manifest in an automated way, or add entries to it in an automated way, because it's easy to go wrong, and if you make a mistake, then it might be a problem. One of the things to easily test this is to hack your host file. If you do it locally, you can hack your host file, add different entries, like I went to offline.example.com. I can add multiple entries, and then it will store, I think you asked this, like it will store a completely new set of files, the same files, under a completely different site name, right? So that's a good way to do it. Also, to make sure that files are really being gathered over the network, check your server access log, right? Use this in the background. In this case, I had the Python simple HTTP server up. Check to see, which files are being downloaded, actually being retrieved from the server, right? And the different codes and so on. That way, it gives you a lot of insight that you're not just looking at some local cache. You might be surprised what you find out. To hack your host file, this is the etc/host file, or on the Windows system settings. You can put any number of different entries there, and then you can go in your browser and they will all point to your local host. But for the browser, from a browser's perspective, it looks like these are different hosts, so it'll do it all over again. So it gives you a little bit of mileage in testing. This quota already came up. If you go over, and I've added a few files in here that were very large, and typically in local storage, we're already seeing that some browsers, some like Opera, for example, give you a very, very nice way to dynamically increase the storage for that site. So, for example, you try to store 500 megabytes or 700 megabytes in Opera, and first it will say, hey, you're going over 10 megabytes, or 5 or 10, the defaults, and then, hey, you're trying to go over this much, and it keeps prompting the user dynamically. Not all the browsers do that quite so nicely yet, so be careful and trap those errors, the error events, because it will just fall on the floor otherwise. Mentioned this already, it works really well with local storage. Obviously, if you're doing something when you're online and now you're offline, you don't have that server connection, so you may be able to store things in local storage, data for that particular application, and then when you detect that you're going back online, push everything to the server. One sort of interesting way you can, with using this particular setup, you can sort of lazily load your app cache. You can load it as you go, because every file, remember that every file you access will, if it has a reference to the manifest, even if it's not listed in the manifest, it will be added to the application cache. So you could actually, if you configured this, you could actually create a regular site, like some large website where people would add files. Every file they were accessing, they would add it to the cache. That would be an interesting use case. But of course, sub-resources like CSS, you can't put the manifest tag on those. So this breaks down pretty quickly, I think. But it's a possibility. Thank you all for coming and staying with so long.